Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I am sorry I'm late today. I'm like 30 minutes late almost. It's 5:27 in the morning. It was one of those mornings, you get up in the morning. I got up at 5, which is admittedly early for some people, admittedly late, come on, for other people. But it is what it is. Got up at 5, and then I had to answer a bunch of emails and stuff like that. So I wasn't able to start stream until right now. So I do apologize for that. On the upside, I think today we'll have slightly less to do than on the other days. I'm not really sure. So we'll see how it goes. So today, rather than going through the fractal flame algorithm as we have been doing for the past few days, today we're still covering bits of the fractal flame algorithm, but we're going to be discussing exactly what makes the Sierpinski triangle, and the Barnsley fern, the Barnsley fern. And so the hope is that by the end of the day, we have some cool visualizations that shouldn't take too long to make with GathVL, such that we can pretty easily, I guess you could say, show in an intuitive fashion what exactly makes the Barnsley fern the Barnsley fern. And that's kind of the hope. Folds coating with ethanol. Thank you guys so much for coming in. Really do appreciate it. I guess before starting, as we're waiting for people to come in, I just wanted to address something. I guess I'm not going to go into specifics here, but I've been noticing that a lot of people, not in our community, but a lot of people in my academic community that I'm in, tend to have a bit of an arrogance towards certain fields. And science communication is one of those fields that people tend to be rather arrogant about. They tend to feel that science communication is beneath them. And don't get me wrong, this isn't as prevalent in OIST as it is in other areas, but I certainly have noticed some people who, for example, let's say you've got a channel with millions of views, and they have millions of subscribers, and the thing is, if you've got a channel with millions of subscribers, your reach is pretty good. That means every time you put out a video, you're going to get at least 100,000, probably between 2 and 300,000 views. That's pretty darn good. I mean, there aren't too many news shows that you can get on, like local news shows, that will have that big of an impact, Like it's also in your exact target demographic, So ultimately, this is a pretty good deal, right? 300,000 unique views in your exact target demographic. That's not bad. And granted, it could be better, but this isn't bad, So it's one of those situations where genuinely I think it's a good idea to engage with, internet discourse and stuff like that, because it does get your name out there. But a lot of people think that, making YouTube videos is beneath them, and I do understand this, but it's not just that, when people think that this is beneath them, that's fine. I don't mind it so much, as long as they don't outright attack me or attack people I know simply because we're doing things that they don't appreciate or understand, Like, why attack me because I'm just making videos? That doesn't make any sense. Sure, I'm making videos. I'm also creating the algorithm archive. I'm also doing a bunch of other things. So I just wanted to say, like, if you are an academic and if you do feel that you're being like somehow ostracized just because of your, I guess, enjoyment or you like how much you watch Twitch or YouTube or something like that, just know that I guess there are a lot of people that tend to think that way. I don't really have a point to this rambling discussion. I just wanted to say that there does seem to be a bit of arrogance on the side of the academic community, and I just wanted to address it outwardly. I don't know how. Just very briefly, again, because it has been bugging me recently. Coding with ethanol, yeah, we're going to be working on Chaos Games now. Technically, we had been working on Chaos Games before. Each of the fractal flames that we were working with was, in principle, its own little Chaos game. So let's go ahead and CD into Project Simuleos. And I'm just going to go into Fractal over here. And we're going to do the same thing over here, CD Project, Simuleos, and Fractal. Now, our visualization for these different fractals, it's going to be rather straightforward. There isn't going to be too much to do. So let's go ahead and start with the Sierpinski triangle. And then after creating the Sierpinski triangle, let's then move on to the Barnsley fern. So what I'm going to do is I'm going to CP. Yeah, I'm over here. I'm going to CP, let's see, go back a directory to visualization. And then I guess, what was the last visualization I did with GaussVia? Oh, actually, it's going to be, one second, LAIOS curve, and then we should have a scout.cpp. So I'm just going to copy that over here because that's what I have been working on. Scout.cpp, and I'm just going to modify it to Sierpinski. Is that how you spell Sierpinski? Oh my gosh. Sierpinski? Yeah, that's correct. Sierpinski. Nice. So we're going to call it Sierpinski.cpp. Let's call it that. All right. Let's go into Sierpinski. Aha. I'd been misspelling Sierpinski. Can it also be spelled with an E? Sierpinski. I'm sure it can't. No, it's always an I. I've just been misspelling Sierpinski for my entire life. Okay, that's okay. I don't mind so much. All right, so let's keep going. Let's go into Sierpinski.cpp. And let's see. So we're going to change this to Sierpinski.cpp. All right, remove some guys here. Nice. And then we're going to say path to Gathiel. Here's the Gathiel. Sierpinski.cpp. Now, I know what you're thinking. Why did I copy code in order to do our visualization today? Well, that's because our visualization today will be mostly done in Gathiel. And I'm going to be honest, I'm still not entirely comfortable with the syntax here. So I'm working on that. So I'm going to output this as Sierpinski. And hopefully this will be okay. So this compilation should in principle work. So I'm just going to go ahead and compile what we have here just to make sure the compilation works. And then after that's done, I'll go ahead and start working on the visualization here. So basically all we're going to do is the chaos game that generates the fractal that is known as the Sierpinski triangle. It's the triangliest of triangles, I guess you could say, where it's like a triangle inside of a triangle inside of a triangle. And that's what we're working on now. Once we get that done, we will then start working on the Barnsley Fern, because here's the thing, the Sierpinski triangle kind of makes sense. When you look at it, and you look at the chaos game for the Sierpinski triangle, everything more or less is okay. Here, let me show you what I mean. Let's go right and quit, let's go into Barnsley.jl. Okay, so here's the code for the Barnsley Fern, and here's the code for the Sierpinski triangle down here, right? So basically what we do for the Sierpinski triangle is we find a random element, x and y, fair enough, between 0 and 1, or between -1. This is slightly different than what it should be. Regardless, it doesn't matter. We choose a random point, right? We then say that that point is element x, element y. We open up a file. Then we have three choices. Choice 1, choice 2, choice 3, right? So each of these three choices basically represent the end points, the edges, well, not the edges, I guess you could say the outlying points on an equilateral triangle, okay? So the idea then is that if we are less than 33%, if our random number is less than 33, 0.33, we go to the lower left-hand point. If it's between 0.33 and 0.66, we go to the upper point, and if it's greater than 0.66, we go down to the lower right-hand point. So basically, we have this way of averaging whichever random point we chose with one of the three equilateral points, right? So we kind of move halfway over here, halfway over here, halfway over there. And as we start moving halfway, I guess somewhat magically, we start generating the Sierpinski triangle, which, let me just go ahead and do new plot. Will look like plot Sierpinski.dat. Let's try this. There, something like this. And again, the problem here is that the points that I chose aren't in the correct locations, so we can kind of modify this. But for the most part, this is correct. Let me go ahead and modify what we have. So let's go into vi Barnsley.jl. There we go. And let's go ahead and modify this so it's maybe a bit more iconic. So let's do $$ here, $$ there. So this is going to be moving to the lower left-hand point. This is going to be moving to the want to generate random number, do mod 3. We could do it that way too. That's fine. The way I see it is then switch cases. Yeah, we could do that too. It's fine. It doesn't matter. Borax148, thank you so much for the $5 donation. I really do appreciate it. Because we have to support science. Thanks a lot, man. I really do appreciate it. We can do it that way too. It's fine. It's just this way makes a little bit more sense because we're relating it to the Barnsley Fern over here. And the Barnsley Fern, each of these have a slightly different probability. So it's like, you know, here we have a 1% chance. Here we have an 85% chance. Here we have a what looks like 7% chance, and here we have another 7% chance. You know what I mean? So like basically the point is we have different probabilities here that we have to take into account. So since we're going to have to bin the data anyway, I figure let's write this one in such a way that it's easier to understand the next one. And don't get me wrong, the case is fine. What language am I using? I'm using Julia right now, but we'll be switching to C++ in just a second. Folster, oh, thank you so much for the resubscription. Really appreciate that too. For science as well. Thanks, Folster, really appreciate it. Gonna put a Simucow in the chat for both the donation and the subscription. You guys are amazing. Thank you so much. But seriously, I do really appreciate all the support you guys are sending my way. I mean, like, oh, by the way, this is a side note. Well, I've been thinking about doing a long stream. Dude, your Hacktoberfest stuff, I'm still waiting on mine over here. Like, I really want my Hacktoberfest stuff. Anyway, JSPP, thanks for coming in. What I was going to say is I want to do a longer stream coming up, but the only day I have free, the only days I have free are Christmas Eve and Christmas, and I don't technically get Christmas off. So I was thinking I could do a longer stream on Christmas Eve my time, which is the 23rd for most of you guys. And I was thinking about just doing a longer stream where we just attack everything, like just kind of rewrite a chapter for the Fourier transform, you know, look up some more information stuff here, just kind of a casual stream, not really anything crazy. And I'm wondering if this is something that we should do, or if I should find some sort of Christmas themed thing that we could do. I haven't really decided. So if you're up for, like, I don't know, kind of a longer stream on Christmas Eve my time, I don't know how long this stream is going to be, but just longer. Just kind of, just so we can hang out. I don't know. I haven't really decided the details, but I'm thinking about doing something like this. So we'll see if we can do it. Anyway, back to the code. So here we move it towards the lower left-hand point down here. Then we move it towards the upper. Is this correct? One second, I have to think here. This should be the upper point. So this should be added plus 0.5. And then down here we should see the lower left-hand point. So that should be correct. So I'm going to go ahead and run this by commenting out the random distribution and commenting out Barnsley-Fern and creating Sierpensky, which I misspelled. Let's just do 10,000 points. And let's run Julia. And I realize it's called Barnsley.dat.jl. That's fine. Give it a second. Now what we're going to do is we're going to run new plot. And let's just run plot Sierpensky.dat. And here we have the try. Oh, what did I do this time? Why is it? Oh, I think I know what I did wrong. Let's try this one more time. Let's do Control D. Let's do Julia Barnsley.jl. Oh, I'm sorry. Let's do vi Barnsley.jl. Pop down here. What do we have here? We have a tree on stream. No, I don't have a tree. I could try. Hey, dude, been watching your videos on YouTube? Oh, thanks, man. I hope you've been enjoying them. We're working on the Fourier Christmas tree transform. Is that possible? How's your 2018? My 2018 was great. I hope yours was also great. How do I put this? So 2018 has been a pretty good year. I mean, this year, basically my YouTube channel got way more popular. I've published a couple papers. I don't know, it's been pretty good. It's been an okay, like overall, I would say there have been some troubles in 2018. Don't get me wrong. Just mental breakdowns here and there, but that's getting a PhD. Like it's all just mental breakdowns. For the most part, I'm relatively happy with where I'm at. And I've said this before and I'll say it again. I'm relatively happy with OIST. I think OIST, the Okinawa Institute of Science Technology, is wonderful. You could add a GIF of the fractal tree and have it looping in some corner in your stream. Okay, there's this thing that I'm not going to be able to do for the video because it's just too soon. But fractal flame movement. Okay, there's a way to make fractal flames move. I'm not really sure how to do that. I'm not really sure at all. So, there's a way to like kind of make it shimmer and stuff like this. So there is something that we could do. There's two things we could do. One, I can try to get the fractal flame on the GPU. That would be a very interesting thing to try. And I'm totally up for trying that on Sunday. You did that. Could you send me a paper on how you did that? Because I can read the paper and I can figure it out. So I think maybe trying the fractal flame on the GPU would be a cool thing to do for Sunday. And then we can kind of loop that into doing it for Monday, which will be Christmas Eve my time, where we do kind of like this moving fractal flame tree and all that kind of stuff. I think that'd be a cool thing to do. That is something we could do. I could not get the fractal flame tree done by by Sunday, which is the time I want the video out. But that's okay, I could probably link it at the end or something like that. So I think maybe we can work on that. Yeah, there's definitely a way to do it. Okay, are fractals calculated per pixel? Yes, they are, but the problem is they're done in the same way that these pixels are generated, in that they require a previous point. And that's the part that's going to be hard to do. Because it requires a previous point, that means that we can't just do random points, right? We've got to do a point that's very specifically chosen in a particular way. GDI, keyboard bugged out, that's fair. You just smoothly adjust one or two variables for each frame and stitch them together. Oh yeah, that's fair enough, I guess. I have such a hard time understanding my linear algebra course. Dude, I know that feeling. My linear algebra course was taught by a person that I didn't click with, I just didn't understand. So let's see, point 1 is 1 and 1/2. Plus 1 and x. Oh, I see, so this should be plus 1/2. Plus 0.5, this should be plus 1. Alright, and then this guy should be plus 1. Okay, this should generate what we want. So now if we do, come on, get new plot Sierpinski.dat. Here's the Sierpinski triangle that you're used to seeing. Sorry about that, just took me a second to regenerate. Hey Trash Talk. Let's see. So here we have the Sierpinski triangle, like you would expect. Let me just say, point type 5, 3. Point size 1. Yeah, I don't know what I'm doing exactly here. All I know is that we have all these points that we're generating, and they look like the Sierpinski triangle. This is what we expected. I need to find a better way to visualize this. That's what we're doing next. But point is, Sierpinski triangle is generated pretty straightforwardly. And admittedly, I understand that the way in which I'm doing this is maybe a bit weird, but again, the point is we basically choose a random number, and based on that random number, we have a 33% chance for it to go to the lower left-hand corner, a 33% chance for it to go to the upper corner, and then a 33% chance for it to go to the lower right-hand corner, right? And so basically the idea is that we have, you know, these three corners. But with the Barnsley fern, that's completely different, right? So we have a 1% chance to do this transformation, a 1% chance to do this transformation, a 1% chance to do this transformation, and a 1% chance to do that transformation, right? And it's not obvious what these transformations are. From my understanding, this first is a transformation for the stem of the Barnsley fern. This is for basically successive leaves after the first two. This is for the first left-hand leaf, and this is for the first right-hand leaf. And that's basically what we got, you know? And that's fine, but it's not obvious how these transformations work. So the first thing I want to do is a quick visualization of the Sierpinski triangle. Again, it shouldn't be too hard to do. And then after I have that visualization, I will then go and I will do a visualization for the Barnsley fern, where we basically pick a random number of points, and then we show the transformation for each of these individual, I guess, transformation. So we start with a random number of points, and then we do the transformation on all the points and move those points to where it needs to go. Let me see what we got. This is one of my moving ones. Let's see, test 5 die. Oh yeah, nice. I'm a fan. I'm a huge fan. Wow. That is so cool. Okay, so Foldster. In my video, I talk about the fractal flame method, and I say you can create some really cool things. Do you mind if I show this when I say, like, you can create some really cool, like, visualizations and stuff with the fractal flame algorithm? Actually, where's your Google Drive with all the fractal flame things in there? Because honestly, like, I think your stuff is way cooler than my stuff. I think in the end, it always looks cooler. Our linear algebra professor is amazing. He uploads the scripts and recordings of the lecture. Oh, that's super cool. The professor just copy and paste the full script of the board 2 times, 90 minutes each week without uploading it. Yeah, so I might. Actually, no, I almost certainly will shout you out in this upcoming video because your stuff is really, really cool. I know you don't have a YouTube channel just yet, but I might just say, I don't know how you want me to shout you out there, but I definitely will. Your stuff is really cool. How lovely. This is one of those lectures I would just skip. Wait, what? You would just skip? Nah, dog. Don't skip lectures. Well, I mean, fine, fair enough. I also hated lectures. Thanks, Holster. All right, let's take a look. Oh, Open link. And this has the GIF in it, right? Dark energy cluster. It does. It does not. Wait. Oh, this is binary clip stuff. 1 second. Let's see. What do we have? Oh, your first video should be coming out tonight. Oh, nice. So then you'll have something there shared with me. So then we're looking for. Wait, where are the fractals? It's fine. Don't worry about it too much. Yeah, cool. So also feel free to like post a video on Discord and stuff like that. I know every time you put a video out, like, trust me, your first couple videos will have like very few people watching. It's just one of those things. It took me a very long time to get even 100 subscribers, you know? And then after that, you kind of grow faster, you know? Yes, this is what I'm looking for. Let me see, do you have the GIF in there? GIF.gif? Oh, nice. GIF. Test5.gif. Oh yeah, cool. That's what I want to see. Yeah, okay, nice. So I'll probably, I will almost definitely shout you out with some of these fractal flames because your flames are just so much cooler than mine. You spent a lot longer on this than I did, I guess. They just look cool. Okay, I'm a fan. There's a couple of MP4s at the bottom. Yes, but I think most of these are test. Actually, wait, what's the difference between test 4 and test 5? Oh, this one looks even cooler in some ways. I only implemented the Mandelbrot set. Yeah, look at that. That's amazing. Okay, regardless, we have this guy. I'll keep this guy up on the side just to make sure we have it. Do a video called 5 eggy experiments. Oh man, my egg video is one of the first videos I made. That was back when I didn't know what I wanted the channel to be. I mean, ah man, that video was basically me doing like weird egg experiments that we had done in a I don't really know how to put it, but just okay, let's try using that. That we did in like some sort of science lab somewhere. It was nice. But and I think it's the same thing over here, so it should be home. Oh, come on, dog. Home, James, projects, GathVL. Let's see if this compiles. Nice. And so if we run Sierpinski, cannot open shared object, no such file or directory. Home, James, project, GathVL. Shoot. What did I do? What did I do? Dang. What did I do? Alright, so let me just go ahead and do git add Barnsley .jl just so I remember we have it. Let's go to vi what I'm looking for, Sierpinski dot cpp. This should be correct. Oh, I forgot the path to get field down there at the bottom. Let's try that one more time. Dagnabbit. Let's try that. Sierpinski. Dang it! Let's see. I was testing different encodings. I haven't seen that one. Let's see. This is kind of a cool. Okay. Oh yeah. I gotcha. Let's see. No other video can hold up with it. To be honest, wait. No other video can hold up to it. Yeah, the egg video is pretty good. When your channel gets so big, I was there when you had 2,000. I'll talk about that in just a second. Just the title alone carries all the swag. I still need to interpolate brightness from between frames. I came that day 3 Blue and Brown shouted you out. Yeah, it was around that time. So let's see. When I started contributing about a month or two later, let's see. I think you came at similar times. My linear algebra professor focused entirely on computation and proof with no application. I found the 3 Blue and Brown YouTube playlist so much more useful in connecting all the dots. Yeah, that's totally fair. FFmpeg doesn't like handling switching videos with high bit rates. Yep, I know that feeling. Also, how I found this channel. I'm very glad I ended up here. Oh, thanks so much for coming in, making things XYZ. You should run this. You should run. It's actually kind of cool. Wait, what? Oh, I don't know how to run this. I don't know what a PDE is. I mean, I know what a PDE is, but I don't know what a, like, I don't think I have anything that can run it. I think that's a processing file. I don't think I have processing anymore. So let's see. Home James Project Scathiel. Home James Project Scathiel. Why? How are you compiling? Okay, am I just doing something dumb here? Let's just move back into Leo's curve over here. And let me just run what I just ran. But this time I'm just going to change this to... oh, what did I even call it? Scout.cpp? Nope, I'm screwing up big time. What am I doing wrong? I just say path to Gathviel. And I have the appropriate path right here. L Home James Project Gathviel. If I didn't have the appropriate path, it shouldn't compile. No, it still compiles. Okay, maybe I forgot. Alright, what did I forget? I'm doing something dumb here. Okay, let's just go into VI scout.cpp. Path to Gathviel. Path to Gathviel. What am I doing wrong? Let's just try compiling this guy. Alright, so we're going to pop this down. And we're just going to change this to the appropriate path. So Home James Gathviel. Projects. I'm sorry. Alright. Home James Projects. And then there's also another one down here. So Home James Projects. Give this guy a go. Then we're running main. That one work. Why? Why does that one work? Oh my! Is this not the exact same command I was just running? All right. So let's move into back into what am I looking for here? I'm gonna look for Fractal. Now we're gonna run the same command, except we're gonna run serpensky.cpp, which should be the same exact file. Okay. Why is that working? What did I do wrong? What is the difference here? All right, let's output it in Sierpinski. Ski. I have no idea what the difference is between this command that I just ran and 1 second. This command. Oh, there clearly is something different though. G++. Wait, I'm looking for it. There it is. That's what I'm looking for. So Gathviel, home Gathviel. Yep, it should be fine. Gathviel, Serpensky, package configs. How's this something? Home James. I forgot a projects down here. Oh no. Oh no, I'm just being an idiot. Oh my word. Okay, so let's go ahead and remove main. And let's just look, where does this output to? Oh, temp video.mp4, mpv temp video.mp4. Good, okay. Oh my word, I'm such an idiot. Okay, so where are we going here? It's a processing program. Processing, I learned today that AIVD has a yearly really hard competition for code breakers. Huh. The AIVD is a Dutch intelligence agency. 3 Blue and Brown has a main series on linear algebra. Yep, he sure does. IDEs, that's really cool. Where's my integrated terminal? Processing is the only language I can comfortably create graphics in. Let's see. How can people even work without a terminal? Oh, I know that feeling so much, though. Let's see. What do we have? I barely use the terminal. What OS do you use? Windows? Well, that's fair enough. But get without a terminal, how? Linux is, wait, what? Linux is a clusterfuck. What? I get LOL a GUI, dude? Look, I mean, I'll be honest. People use whatever operating system they want. I'm not going to let this turn into an operating system war. The thing is, I use Linux because Linux is the easiest operating system to do what I like to do it in. Like, that's just how it is, you know? Sure, Mac is a close second, but Linux is still the easiest. Windows is just really difficult for me to do stuff that I enjoy doing in. So I just don't use Windows, you know? Same is true for Windows users and Linux and Mac users. There's always some software that you really like using. There's always some method that you like doing that's easier to do in your operating system. That's how it is. What do we have here? Our university is known for focusing on mathematics and computer science. That's a problem. Oh, that's super cool. Let's see. I really need to learn Ubuntu for my academics, though. I'm trying to make the switch from Windows to Linux, but it's like quitting cigarettes. Yeah, I do understand that. I mean, it's the same thing here. Every time I use Linux, or every time I use Windows, I just get really... I find it hard. Like, it's very difficult for me to understand what's going on. Let's see. Cause you don't need to look for a dual boot. Oh yeah, fair enough. I do use command line commands, Jupyter notebooks, though. Yeah, that's the thing. I'm not a very big fan of Jupyter notebooks. I know a lot of people are. Don't get me wrong. I totally understand people that are. But it's just not my thing. You know, like, I know a lot of other people really like it. That's fine. I just don't like them. I can't like them. Aren't you nervous when teaching a lecture with so many students? Meh. I mean, you kind of get used to it. And honestly, I haven't taught lectures with more than, I think the largest lecture I've ever taught had 40 students in it or something like that. It's not usually that big. I mean, don't get me wrong. I've done like science shows with, you know, a few hundred people in the audience. I think the largest I did was maybe 500 in the audience, something like this. But that's about the most I've done. dd if equals 0 of, yeah, well, who's going to make that mistake? Like, that's not a command you would naturally run. If I have a proper package manager on Mac, is pretty, not having a proper package manager on Mac is pretty BS. I agree with you there. But honestly, you know, what is it? Brew is not bad. It's okay. Like, there's some security issues, but it's okay. Okay, so let's go ahead and get this guy drawn. So we have this draw scow command. I'm not going to use that. Down here, I'm going to change this up. So we're just going to have a Sierpinski. Sierpinski. All right, there we go. Let's go. And we're just gonna delete this entire thing because we don't need it. So we're just gonna call it Sierpinski and let's go. And we're also gonna have to go up here and we're gonna have to include random. Okay, so let's just go ahead and do this. So we have black and white. Do we need other colors? I'm gonna say yeah, we probably need other colors. But I don't know what those colors are gonna be yet. So I'm just gonna kind of delete things that we don't need. Do we have a circle? We don't have a circle defined yet, but that's okay. We'll figure this all out. So let's just go ahead and DD here. DD. We're just deleting everything because I'm very good at programming. Okay. So the first thing we need to do is basically generate the 3 outside points of the triangle, right? So we're just going to create an std vector using vec. So we're just going to say, yeah, so we'll use vec here so as our position. So we're going to say std vector of vec, where vec is a 2-dimensional component. And we're just going to define these points as, I guess, actually, where do we define these points as? That's a very good question. So we're going to want them to be between 0 and 1. So I guess we're going to define these guys as, we'll say triangle. That's not how you spell triangle. Let's try this again. Triangle. And we're going to set this equal to something like, we'll do 0, 0. Let's see, 1 in x. I'm sorry, 0.5 in x, 1 in y. And then we're going to want to do 1 in x, 0 in y. Okay, so this is going to be our grid between 0 and 1. These are going to be the points before they're, you know, modified to be on a grid between, you know, to be put on some sort of pixel grid. What do we have here? By the way, Windows. So if you click check for updates in the 3rd, 4th, or 5th week of a month before the next B update has been released, you'll probably get a C or D update installed on your system. If you never click check for updates, you'll stick with the better tested B updates. Huh. Look at Jupyter Lab, SOS kernel. Let's see, Windows 7. If you click check for updates button, you can become a beta tester. Is there a fixed days for the stream, or is it just random? No, I stream basically every day from 5 to 7 o'clock a.m. Japanese Standard Time. Sometimes I'm late. Like today, I got in at 5:30, which admittedly is late. But for the most part, I'm pretty consistently here every day at around the same time. Let's see, what do we have here? 8 to 10 are trash for Windows. I don't know. I feel like, I don't know. It's okay. I thought that 10 was okay. I don't know. I've never actually used Windows 10, so I don't know. Let's see. You can click check for updates. Let's see. Is there a fixed day for stream? I don't know where to start with notebook stuff either. Let's see. So kernels let you pass information between languages. I'm missing a lot of stream. But seriously, Linux Software Library is the most disgusting collection of utilities I've ever had the pleasure of browsing. Could you expand on that? I'm actually genuinely interested in what you mean, because honestly, I find Linux software to be pretty darn good. But again, this depends on what you need for. Like, I use high performance computing all the time, right? So I'm basically just interfacing with supercomputers, right? Like, that's the point of my computer, just to interface with a supercomputer, right? And there's literally no other operating system in the world that can be run on a supercomputer. I mean, sure, you have a Windows supercomputer, like one or two, but they're not in the top 500. And I don't think anyone's done a Mac supercomputer. It just isn't, it doesn't make any sense, you know? So I would argue that most of the terminal utilities are pretty darn good. And of course, you could argue they have to be good because that's, you know, the main strength of using a Linux desktop. But, you know, that's something I believe, but I don't know about other people. The only reason I use Linux is because it's cool. I think it's cool, and it makes a lot of programming stuff easier. Yeah, exactly. That's the thing. I would argue that, in talking about usability, well, that's the thing. Like, I don't know what you mean by usability. Like, for me, and the workflow that I have, it's perfect. Like, it's literally 100% perfect. But, yeah, but for people who I guess are not used to this workflow, it's a bit different. Yeah, I'm listening. So you say, I'm going to have to sit down and install this, and get to work ASAP. That's super easy. Yowert, NVIDIA. Well, okay, fine. So I don't have Yowert installed in this system, but sudo, what do I have? Yay -s NVIDIA. Something like this. I'm sorry. But anyway, point is, yeah, here's all your NVIDIA utils. It's super easy to find. It's much easier to do this, I would say, than I would say to do this on, like, Windows, where, for example, Windows, you know, you have to go online, you have to download a driver, you know, you're like maybe 25% sure this driver is the right driver when you install it, so you might be accidentally installing the wrong driver, and then, you know, you got to do all this other stuff, and the fact that you have to go online to install the software to begin with means that you have an additional hassle of having to open up an internet browser. It just gets super complicated. Meanwhile, with Linux, all you have to do is just say sudo apt-get install, done. You know, super easy to do. You know, my development setup is in Linux. Ubuntu works out of the box. Install VS Code, done. That's the thing. I don't think I've ever used VS Code. I find it a bit weird, but that's fine. It is what it is. You know, people like what they like. Anyway, I just, again, I'm not knocking it. I'm just saying that I'm interested. I'm still interested. It's hard to get non-free Wi-Fi card working on Linux. That could be true. That could. I don't know. I mean, all the Wi-Fi cards I've ever had have worked just fine. But I've never had, I guess, a proprietary Wi-Fi card. I didn't even know such a thing existed. But if it does exist, which it does, obviously, then yeah, I understand. Let's see. With the same with Mac, my Linux setup would look similar. Let's see. Every piece of hardware produced. Looks like we've got a problem here. Glass of ethanol. Hey, how are you? Let's see. To have Windows drivers. It's guaranteed to have Windows drivers. Yeah, I don't know if that's necessarily... Yeah, okay, I guess that's true in most cases, I would say. Yeah, I agree with C252. I've never had a driver issue on Linux. I mean, maybe a graphics driver issue back 5 to 10 years ago when I was using an AMD laptop. I think I had maybe some issues then, but even then it was fine. Like, it wasn't that big of an issue. Yeah, same here. Never had a problem with it. If you're younger than me, I get to keep the username. So I don't know. That's what it is. Like, again, don't get me wrong. I understand that there are problems with Linux. Definitely are. It's just for my workflow, I've never run into a problem. And I'll be honest, like, I usually run into more problems with Windows. I know you say there's a lot of hardware support, but again, I'll be honest, like, every single time I have a Windows laptop, there's always something wrong with it. Always. You know, it's like the start button doesn't work or something like this. It's just like something breaks and you can't fix it. You know, at the very least with Linux, there's a workaround, you know? But I don't know, this is obviously my own perspective. as someone who has had a lot of trouble with Windows in the past and has absolutely no trouble with Linux, which I understand is the opposite case for a lot of different people, you know? Just from my own perspective, I've had a lot of hardware issues with Windows, and I've had very few hardware issues with Linux, and that's how it is. That's just my own personal. 19 and 20. Let's see. Try to SSH into a remote machine with native Windows tools. True. You have to use like, you have to use MOBA Xterm, which is garbage. Let's see. 21. The only thing I don't like about Linux is that when the new hardware comes out, it takes a while for kernel devs to write drivers. That's fair. I do totally agree. Use some Warframe. I use Cygwin for SSH. Easy peasy. Yeah, I guess so. It's just Cygwin isn't properly interfaced with your Windows machine exactly, so that you end up having to, like, if you're having to SCP data from the cluster onto your own machine, it's a bit more complicated. I think you need to do photo editing. I think if you need to do photo editing in the command line, yeah, for photo editing, GIMP works just fine. I mean, I do understand that maybe it's not a professional tool, like maybe there's some issues, but for everything I've had to do photo editing for, GIMP is fine. Everything for video editing, Blender is fine. I mean, I agree, there are some software that we're missing, but what we have is fine. It's not the worst thing in the world. Yeah. Did you say Git? Yeah, I like Git. Git's nice. Git's a very good version control system. I'm a fan. Okay, so what we're gonna do here is we have the 3 triangle points. So now what I'm gonna do is basically add in a circle. The thing is, I forgot how to do this. So let me go ahead and open up a new terminal over here. And let's just take a look at some sample code that we have to draw circles with, because I'm an idiot. So here we're gonna draw the 3 triangle points. So we're gonna do 4. Int I equals 0, I less than triangle dot size. Come on, why can I not spell triangle? I misspelled it the same way both times. All right, triangle dot size plus I. Pop down here. Now we're just going to draw a circle for each of these points. So let's go ahead and cd into projects, Simuleos, GathCL, and let's take a look at vi viz test.cpp, and let's look for a circle, because I know we have a circle in here somewhere. Ball, ellipse is what it's called. That's fine. All right, so we're going to do here, and we're just going to add basically an ellipse at each of these positions. Now the thing is, our world.scene is 1280 by 720, so we probably want to put these points somewhere that fits into our grid, and I'm not exactly sure where to do that. What do we have here? Desktop.github.com. What? What? That sounds amazing. Oh, this wasn't what I was thinking. It's just a desktop thing. Yeah, fine. I was thinking this was actually a desktop on github.com. Like someone had done like a github.io page that somehow is like a Linux desktop on it, but this is just a desktop application, which is fine. I don't like the desktop application because you can't do as many tricks with it, or at least you couldn't a year or two ago when I was using it then. But it's okay for people who have to use GUIs. It's okay, but for people who have the command line, just use the command line. It's better, you know? Like in almost every way, the command line is better. But this is, again, I'm aesthetically attracted to command lines. And I don't mean like, okay, I don't mean like, I mean like, I like the terminal. I just like the way it looks. It looks really nice, you know? And this is just, I appreciate it, you know what I mean? Let's see, a software that I use has no alternative in Linux, so I just stick with Windows. Yeah, that's totally fair. I do understand. Out of curiosity, what is the software? Can you sign commits with GitHub Desktop? I believe you can. I don't know. I have no idea. Git commands aren't that complicated. The only reason I use it for personal projects, GitHub Desktop does not support commit signing. Oh, huh. I had a bug in my shape predictor because I titled one of the training folders Tringle instead of Triangle. I'm glad I'm not the only one having trouble with it. Let's see. I can't even sign commits. I mean, I guess that's a problem if you're working on a team project or something, but yeah. There's Git for Windows. Yeah, this is also true. And nowadays, Windows has the Ubuntu subsystem, which basically is an inbuilt like terminal for Windows. So again, fine, fair enough. It's not that big of a deal. Like if you're using the Ubuntu subsystem, you can probably get things working just fine. But again, it's just a huge workaround. Because the operating system itself doesn't natively support bash scripting, and it's kind of like, look, if everything you do is in bash, if everything you do is through the terminal, then Windows is a poor operating system to choose. Now, admittedly, if everything you do is via GUI, I would say that Linux is probably a poor operating system to choose, and I would say if you're wanting to choose the best of both worlds, choose a Mac, you know? And this is the way I see it, you know? If everything you do is like on a cluster, if everything you do is through the terminal, If you enjoy and you feel like you like working with CLIs and stuff like that, Linux is definitely the way to go. But if you want a middle ground, go with the Mac, and if you want super GUI focus, go on Windows. This is kind of how I see it. And granted, yeah, Linux has its GUIs, but again, the reason I use it is because I love being a power user, and it's hard to be a power user in other operating systems. Oh man, this ended up being a huge operating system debate. I'm so sorry about that. Let's see, question is how easy is interactive rebasing and so on? It's hard. Let's see, but then you need a new program for every tool, one for Git, one for GPG, one for SSH. With a proper terminal, you just type tool arguments. Yeah, that's fair. To be fair, you can install better terminal emulators for Windows, and you can get a decent CLI. Yeah, again, I agree. But it's a lot of hassle compared to Linux. Yep. You have a good thing though, you have Visual Studio. How can you both focus on your program, talk with chat? I'm doing a very bad job of doing both. Like, honestly, like, look, I've done very little coding. I'm just talking to chat now. Like, that's all I'm doing. Like, I'm not even trying to program. That's pretty awesome. Yeah, let's see. Mac OS is greater than Windows. Visual Studio is trash. Oh, man. Oh, we have so many opinions. We have so many opinions here. DevCCP is the best IDE. Oh, man. Okay, here I am. I'm just going to start coding again in my VI terminal over here, and let's just pretend we're from the 1970s. Okay. So we're just going to go ahead and create our ball over here. So we're going to say, I guess we're going to have to create a vector of objects again here. So we're going to say triangle here, which are the different locations. And here we're going to say std vector. Oop, vector of, actually, what are these guys? So I don't like using auto when I don't know what they are. So let me just pop over here. And let's go into, 1 second, VI. Oop, hello. What am I looking for here? Laos curve, and just look up scow.cpp. And I believe we have some sort of vector here already, shared point rectangle. So we're going to say shared pointer ellipse. So it can be std shared pointer ptr, and we're going to say ellipse over here. And now we have that, and we're just going to say it's going to be triangle points. Maybe this should be triangle points. Oh, I don't know how to call this at all. All right, let's just call this triangle. And we're going to have it have 3 elements in it. All right, let's go. This is clearly proper coding notation over here. Okay, so now we have the ellipse. And we're just going to define each of these points in the ellipse. So we're going to say triangle of I is going to be equal to. Now, here's where we have to give it a size, a position, a location, all this kind of stuff, right? So first, I guess we're going to give it a size, I want to say, is the first argument. Yeah, I don't know what these arguments are. I'm going to have to figure that one out too. Dang it. What do we have here? I missed a lot of stuff here. Okay, I said Linux is better than Mac. Thanks, JSPP. Let's see. BSD is the way I'd imagine Linux was when it was actually really hard to use. It could be. I don't know anything about BSD, if I'm being honest. Like, I've heard of it. I know it's something that people talk about, but that's as far as I know. Oh, who uses Emacs? Trash talk. That is some heavy trash talk for you. So I use Emacs for small stuff and VS Code for big stuff. I just don't use Emacs. Is the Vim key binding surprisingly nice? Whoa, whoa, whoa. Now that is sacrilegious. Emacs with Vim key bindings? Oh, man. Command line is so good. Let's see. I play the piano, so I might be able to do shortcuts. If you need to deal with things you can't deal with in GUI. Let's see. Hey, Radu. So other than that, GUI is much better for workflow. It just depends. Again, it totally depends on your own person. For me, I don't like using GUIs. If I have a choice, I will always use a CLI over a GUI. I just don't like GUIs. They're weird, blah. But I like CLIs. I really do. That's why I code in the terminal. That's why I do everything from the terminal if I can. I just really like it. Guess let's make your name all caps. I don't think he knows I'm here. No, I do. Hi. I just... let's see, coding with ethanol, wholeheartedly disagree. I'm way quicker and more precise to keyboard compared to mouse. Yeah, again, agreed. Yeah, my mouse, I always misclick. Keyboard, might mistype, but this tab autocomplete helps me out a lot. I think, you think the sacrilegious, I guess I shouldn't tell you about the org I made. I mean, you guys know the history between Emacs and Vim, right? So, Church of Emacs. This is my favorite bit of Linux history. I mean, it's so amazing. The editor wars of, oh, I don't know where. I don't know where. Anyway, point is, like, people always argue between Vim and Emacs, and there's this thing called the Church of Emacs, where people basically created Saint Ignatius of the Church of Emacs, who was Richard Stallman, and he was like, you know, the head honcho. And basically there was this fight between the cult of VI, where they were like debating between each other, and basically like VI said that Emacs is a great operating system lacking only a decent text editor, saying that towards Emacs, and Emacs was like, you could play a game based on trying to get a new user to quit VI, you know, this kind of stuff. It's just super interesting stuff, man. I love these little tidbits of Linux and Unix history. It's the best. Yesterday someone came onto our Discord chat whose name was ZSH, or ZHSSH for people who are not American. Anyway, it doesn't matter. He came in, and it was the funniest thing, because immediately everyone recognized him as you know, the shell, ZSH. And then Berquist changed his name to Bash. And I think C252 changed his name to another terminal shell. It was the funniest thing I think I'd seen in a while. And I was sitting there laughing at my desk. And a friend of mine was like staring at me, and he was like, "Why are you laughing?" I was like, "Oh, this is the funniest thing." And then I realized I couldn't describe it to him, how funny it was, because he doesn't know. Like, he doesn't know you guys. He doesn't know the terminology. He doesn't understand the joke. It was just so funny. It was so funny. And it was just, it made even more funny because I knew I couldn't describe it to anyone. I don't know. I just was laughing for like maybe 10 minutes. I was sitting there and like I kept chuckling to myself because I thought it was funny. What do we have here? C252 started with Space Max, then went to just Emacs plus Evil. Yeah, fair enough. What am I missing here? I am having trouble following the chat and doing code at the same time, so I'm going to focus a bit on the code now, and I'll come back to chat when I can. I might not be able to read all the comments, but I'm going to do what I can. So let's go ahead and get this triangle built in. So we're going to say this triangle is going to be equal to each individual component of the triangle is going to be shared legs. Where do I define legs? So we have a location, legs I. Here we are. So we're going to do std make shared, and we're going to say ellipse. Now the thing is, I am not sure. So it's location, size, rotation, and then fill, I believe. So we're going to have to give it a location, we're going to have to give it a size, and we're going to have to give it a fill. So let's go ahead and define all these points over here. So we're going to do dd there, and we're just going to say location, size, rotation, and fill, which is just going to be 1. We're going to make sure it's filled. So for the rotation, I don't think we're going to need a rotation here. So I think we can just read in 0 for the rotation. For the size, I think we can define them all to be the same size. And I think the size we're going to define them to be is going to be 100 by 100. All right, because they're all just going to be circles. No big deal there. Okay, and now after this, we have to define the location. So we're going to see std vec location, and we're going to basically make this fit our grid. So this is going to have to be in pixels. So 0, 0 is going to be the lower left-hand point, and we have to figure out how to fit this into pixels. Okay, so how do we do this? Well, we know that the 0, 0 point, we're going to want to be on the lower left-hand corner. So how about we say that we start at the center of the screen, and then we go left, right, up, and down from there. So let's say we have world.size. Ooh, okay, what do we actually have for the world size? World size.x. Size.x is going to be the initial x location. And now what we're going to do is we're going to subtract out our individual points location here. So we're going to say world.size.x times 0.5. And now we're going to subtract. How are we going to do this? I guess what we want is world size.x, and we'll make it so that this triangle is going to be, if it's 720 in the y direction, 1280 by 720. Actually, no, let's change this. So the camera is actually 1920 by 1080. 1920 by 1080. All right, we're gonna do the same thing down here. And 1080. Again, I'll get back to chat in just a second. Let me go ahead and get this guy going. So we're gonna say minus, and it's gonna be 500. 1 second, I gotta think here. So it's gonna be minus 500 plus 500 plus 1,000 times triangle points. Goal points. Come on, dog. PTS of I. Wait a minute. Is it I 0? All right, let's go. And we do the same for Y. Should be something like this. I don't know. Making up stuff now. Here we have that. And there, and this will be 1. Except I think this is going to have to be plus and minus. Plus and minus. Something like that. So the whole grid is going to be 1,000. Then we basically just multiply by 1, 0.5, or 0, depending. And I think this should be okay. Yep. Something like this is probably correct. Add a semicolon at the end there, and hopefully this will create the points that we want. So we were going to add the layers, now we're just going to add the objects. And so I guess, yeah, I guess we'll just do it down here. So we'll say triangle of I and 2. We're not going to add the body, and we're not going to add these objects down here. And then we just do world update and world.clear, and let's see what happens if we run this. Quit here. And we're going to run Sierpinski here. Of course, we're having some issues. std vector, std vec location. I think it's just vec location. What was I thinking? Try that again. Okay, nice. It's cleared a couple times. What else did I screw up on? Error. Let's see, 500 triangle points 0. I think this is a dot X. And I think this is a dot Y. 1 second, I'm getting to chat as soon as this compiles. Clear. Try it again. And what's the next error? The next error is too many arguments, 0, 0. Ooh, okay, what? Make sure to ellipse, vector. Oh, maybe that's because I need to call this vector. Yeah, it compiles. Yeah, it runs. All right, back to chat. What do we have here? Is your lab computer Windows? I don't know if that was talking to me or someone else, but my lab computer is actually half Mac, half Linux, actually. So sometimes I'll use Mac, sometimes I'll use Linux. Berkowitz still has the name Bash on Discord. That's so amazing. All right, I have more universal and more control. Let's see. If you need to stream from a lab computer, I just copy dev. If I need to stream from a lab computer, I just copy dev CPP off my flash drive and run it. Let's see. We have Linux and Windows computers pools at my uni, and if you SSH into my uni, you actually get computing power from one of the Linux machines. Yeah, I think you always get the computing power from Linux machines. It's hard to set up servers that it appropriately fits, like on Windows or Mac. Usually most servers for computation are Linux. Let's see. I was going to stream, but then Simulator started streaming. Well, thanks so much for being here. I'll be done in about 30 minutes, though. Unfortunately, I think we're just going to be able to get the Sierpinski triangle done. It doesn't look like we're going to be able to get much more. But that's how it is. That is perfectly okay. That's pretty sweet. And we also have Uni at GitLab. They apparently give you space to host your private web server. I am browsing the chat now. Gathers me cool that they have... Wait, why not make your own I have a Git server and Git web on an RPI? Oh, huh. Yeah, okay. Let's see. True, my university... Whoa, okay, 1 second. My university has a web server. All users, you just have to make directory, put HTML. Yep, that's fine. You need to have a degree from high school, and they're looking for your marks. Yeah, okay, but for CS, no barriers for STEM. I wish I didn't need to take SATs. They aren't even hard, but they get super annoying. But dude, I know that feeling. I know that feeling so much. Let's see. I like GUIs, but most IDEs these days are mostly spying on you with telemetry, and some are done by design. Let's see, what do we have here? Atom VS Code, not if you compile open source code yourself, but I can't really code in Vim. I'm just too used to IDEs. I used my IntelliJ CE for some time, and they downgraded their community edition, yada yada. So it doesn't work with some old free plugins, induced obsolescence, and now I have to pay for ideas, GoLand. Oh well, I'm not paying at work, and I just get free license. Yeah, look, I understand that struggle. Like, I'm just so used to coding in this way that I can't code in any other way. You know, it is what it is. And I totally understand. Yeah, but isn't it freaking awesome that you can SSH into Unity and get resources? Dude, it is so awesome. Like, I cannot tell you how amazing it is that we have a supercomputer that does literally everything we want it to do. It's so freaking cool. And like, I know other people don't think so. I know that, you know, they take the supercomputer for granted, but this supercomputer we have in this university is by far one of my favorite supercomputers I've ever used. And I've used quite a few. I just like it so much because you have immediate access to everything that you want. Let's take a look at this image that we have. So MPV, temp video.mp4. Okay. We had one circle. That wasn't exactly what I was expecting. Let's see what I did wrong. So vector ellipse, I think maybe I screwed up. I think maybe I screwed up and mixed up the size and the location. Let's try this again. No, let's try that, MPV. Okay, nope. No, that's even more wrong. Whatever I did just then, that is incorrect. Let me see what I'm doing here. So I thought it was initially a vector of size 100 by 100, but maybe that's the wrong part here. Maybe it's 10 by, let's try 10 by 10. Let's give it a location. Okay. Let's try running this and let's see what we got. So we're going to do this, Sierra Penske, and MPV. Okay, so we have one dot. Here's our dot. It is here. Where are our other dots? Why is it so close to the center? These are questions that I have no answer to. Okay, so could be we have the triangle points, which are at 0, 0.5, and 1, right? So we're going to say world size dot x times 0.5. Then, so this is going to bring us to 960. Hey, Tim, thank you so much for hosting. Really appreciate it. I hope you're having a wonderful day. And feel free to come in and chat. If you guys don't know, Tim is also a streamer. So feel free to check him out if you haven't already. Thank you so much for the host. I really appreciate it. Okay, so here basically we have world of size.x. Figured it out. I figured it out. I'm not saying I'm a genius, because I'm not. Triangle. Yeah, we have a triangle. 1, 2, 3. 3 points. Let's go. Okay, so now let's go ahead and modify this slightly. So this is going to be minus 400. This is going to be 800. 800. 800. And I guess the vector size we're going to change to 50 by 50. Let's give this guy a go. G++. Sierra Penske. Okay, I think we can get this done. So let's do MPV. Here's our 3 major points. They're a little bit big, so we'll modify the size here. Change it to 25 by 25. Yeah, let's do 25 by 25. What do we have here? I did not end a stream, just changing who I channel was auto-hosting. Oh yeah, fair enough. I still really appreciate it though. But how goes Simulators and Turtles? I appreciate the shout out. Yeah, thanks a lot. I really appreciate you coming in. Let's see, what do we have here? I think a lot of people on this channel, they do watch your channel too. Keep it the main. I think you just said lol. I don't think did I miss anything else? To have a Bitcoin miner which runs in the background. Okay. So now what we're going to do is we're going to basically add an animator for these 3 circles, okay? So the question is, how do we want to add this animator? And I'm guessing what I want to do is, I'm so glad the cowsay command has privileges, so it can like generate the cowsay function very quickly. You know what I'm saying? Okay, let's just go. Triangle of I, and we're just going to say add animator. Okay, and the animator we're going to add in is going to be a vec animator, and it's going to be on the size. Okay, so we're going to say this is going to be from, we'll start them all from 0 to 50. Let's do 0 to 30. Okay, so it's a 30-second drawing phase, and we're just going to do triangle of I, pointing to the size. And we're just going to say it's going to go from 0, 0 to 25, 25. So it's going to be vec of 0, 0 to a vec of 25, 25. All right. Add something there and change this to 0, 0. Oh, dude, C252, thank you so much for the bits. I'm sorry that I missed the 1 bit before, but thank you so much. Really appreciate it. Let's go over here, and I'm just going to run this guy. G++, Sierpinski, and we should see, hopefully, look at those. Wow, look at that amazing animation that we have there. The 3 points being automatically generated. Oh. All right, so now we have to generate thousands of more points. We will get there. So those are 3 initial points. Those are fine. So now we just generate a whole bunch more points. That's what we need to do next. Let's see. JSP, you don't need to support Microsoft. They are not about loving Linux distros like they say they are. If they could bring down all Linux distros altogether, they would. They've open sourced a lot of things to profit in one way or another. And they even give money to the Linux Foundation to have some leverage on the board. Yeah, I guess that's fair. I played this on December 26th. 6 a.m. to 8 p.m. Eastern, and I highly recommend being there if possible. Major reveal. Oh, cool. Does your HPC cluster run Kerberos? I don't think so. I mean, wait, Kerberos, is that a distro? I'm sorry, I don't know what this is. I'm so sorry. No, I have no idea, if I'm being honest. Named, I have not heard this one. I haven't heard of this one at all. So I'm gonna guess not, because I know most of the, if you give me a name, I should be able to, like, I know most of the system. So I'd say that we don't run that. I don't really know, but I would say we don't. Okay. Buttercake doesn't like emotes. So the random number function in, let me just take a look here. So let's do rand is C++. I kind of forget how rand works in C++. I always forget. Okay, so if I want a random number, let's say, I think I'm just going to use a rand. I'm not so worried about this. So let's go ahead and just do this as we need to do it. So now we're going to generate a bunch more points, right? So we're going to say for, let's move up here and read in an int n. And pop down here and add that int n into Sierpinski. And the int n that we're going to read in, let's say, is 1,000. Okay? And let's see how slow this gets. So for int I equals 0, I less than, what am I doing with my life? I less than n, there we go. plus I, pop down here. All right, cool. So we have all those points. So basically now we're going to add an ellipse for each of these guys. And we're going to do the Sierpinski, implementing Sierpinski. Sierpinski triangle. Yep, let's go. Statement, Microsoft just supports OS and Linux for profit. That's fair. I mean, that's what companies do. It is what it is. I'm not going to argue that. Let's see. Oh man, now we have duels and everything. Oh, it's really hard to follow the chat now. Let's see. Also, Simulus, if I don't have my video out tonight, but you want to shout me out anyway, you can just list my Twitter instead. Okay, yeah, that's fair. But the video will be out on Sunday, my time. So, I mean, there's still a few days, you know? No big deal there. So, Sierpinski triangle, let's go. So first thing I'm going to do is create a location. So this location will be somewhere random in X and Y. So we're going to say location, let's say vec location. And this is going to be equal to, oh, how am I going to do this? I guess I'm just going to do it this way. World, I should be between 0 and 1. And then we use this, okay. Double R&D is going to be equal to rand, right? And then we're going to do mod, let's do 1,000, 10,000, why not? I don't care. And then we're just going to divide that by times 0.0001. Is that correct? Okay, so we're going to do mod 1,000. This will give us a random number between 0 and 10,000. Then we're going to multiply by 0.0001, and that should get us between 0 and 1, right? Do I need to add a 0? Am I wrong here? Oh my gosh, what is 10,000 times 0.001. Nice. Okay, I can do math. Hey, Code and System Security, how are you? All right, so here we have the math done. All right, let's go. Over here. I'm such an idiot, and I'm so sorry. I realize, yeah, we're just using rand. We should do a better random number generator via, you know, like some sort of Mercine twister type of guy. But we're doing what we're doing. Okay, so we're gonna do world. What am I doing here? So basically, we have the point that we have before, right? So let's go ahead and generate our first random point. Okay. So we're gonna do that. So first we generate a random point. First, generate random point. Okay, and up here, I guess I'm just gonna comment 3 triangle points. All right. So first we're gonna generate a random point. That's not how you spell random. Let's try this again. Let's see. I got my homework for programming. We have to implement the Sierpinski triangle. Ha. Yeah, it's relatively straightforward. Okay, so first we're going to generate a random point, which is going to be anywhere on our board. So we're just going to say, I guess we're just going to call it point. So we're going to say vec point, and this is going to be equal to, okay, we're just going to say it's going to be equal to rand mod 10,000 times 0.1, all right? And we're going to do the same for y, rand mod 10,000 times 0.0001. Okay, so now we have an xy location that's between 0 and 1. And now we're just going to do our random number generator. So we're going to be using the point that we have. So here's our random number, and we're going to say if, understandably, there's other ways to do this. This is just what I'm doing. So if I is less than or equal to 0.33, pop in here. And we're going to say if I is greater than 0.33 and, where are we? And this shouldn't be I, this should be R and D. Down here, R and D, and R and D is less than or equal to 0.66. Okay, this is the next case. And then the final case, we're going to say if, or else is all we need here, else. All right, let's go. All right, so basically we're taking the point location that we have here, and based on the random number, we are modulating this random point. So now we're going to say point is going to be equal to 0.5 times pt.x and 0.5 times pt.y. Nice. We're just going to do something similar down here and down here. Okay, so this is going to bring it to the lower left-hand corner. So now we're going to have to bring it to the other corner. So we have 0.5 times pt.x. So now we're going to do I'm so sorry, guys. I'm just out of it today. Barnsley.j, I'll pop down to Sierpinski. Okay, so this is going to be 0.1 plus 0.5 divided by 2. So this is going to be our divided by 2. So now we're going to do point.x. And then this one should be, 1 second, I'm thinking here. Should be plus 0.5. Yes. Because it's plus 0.5 in x. Wait, am I correct here? Should be plus 1 in y. Yep, okay, good. And so this next one should just be 0.5 times point. This is plus 1. And now we have 0.5 times point y. Yep, and that should be correct. Okay, so basically the idea here, like I said before, is one of them is bringing it to the lower left-hand corner, one's bringing it up here, one's bringing it down there, and we just average, all right? So now we have the points. This point is somewhere in between 0 and 1, right? So now we're going to say if, we'll say I is greater than 20, something like that. Then we're going to go a little bit forward, and we're going to define a location and basically create an ellipse and everything. So we're going to do this guy up here, just down here. So we're going to say vec location is going to be equal to basically this exact guy that we have here should work. It's just called point instead of triangle points. So you're going to do, instead of triangle points, it's just going to be called point dot x and point dot y. Okay. So now it's on the grid. We know what we're looking at here. We have a location. So now we just have to basically add the object to the world and hope that this works out. Let's see what I'm missing over here in chat. Got my homework programming. Let's see. Did you know in 1991 there were 2 hypertext protocols, HTTP and Gopher? I think you'll like Gopher. Huh. I don't know about Gopher at all. No, wait, maybe I've heard of it. So anyway, we have a location. Let's pop down here. And I'm guessing. I'm going to try something. All right, I'm going to try something over here. So let me just do, let me define auto std make shared ellipse. All right. And we're just going to give this a location, and we're going to give it a size of vec. We'll just give it a size of 10, 10. No, we'll give it a size of 5, 5. All right. So it is a size of 5, 5. Then we're going to do 0 for a rotation and 1 for a fill. All right. So we have this guy. So we've defined our ellipse. And I forgot to call it something. So let's go ahead and add a semicolon at the end. And we're going to call it auto. Ball. I'm sorry. I can't think of anything. And now we're just going to do world. Dot add object. And we're just going to add the ball. On layer 1, we'll call it. But we haven't added the layers yet, so maybe we should do it the following way. Maybe we should yank 6 yank. Actually, yank 7 yank. Sorry, D7D. Ah, dang it. D60. There we go. And let's pop it up here. Okay, let's see what happens if we compile this guy. Wow, look at that error. 59. Autoball std make shared ellipse location. Okay. I'm doing something wrong here. Autoball. I forgot an equal sign. All right. Okay. Oh, yes! Almost. Almost there. What is your problem? So we have the points, right? Right, the points are being generated correctly. We're just doing something dumb. Okay, but that's okay. That's okay. We're getting there. All right, so we have the point times 0.5 times point.x. Basically, this means that our lower left-hand point isn't doing what we want it to do, right? Why is this point? We're also missing some triangles, so I've got a feeling I'm doing something dumb here. Why is that going that way? Okay, so now the question is, what am I doing wrong here? And that's a very good question. I have no idea what I'm doing wrong here. So let's just go ahead and DD here. We have the objects all being added. I'm going to go ahead and add an animator to the ball since I have no idea what else I'm doing wrong. And I'm also going to add a color gray up here for the individual ball points. So let's go up here and let's just say color white, and we're going to yank paste color gray. I'm American, I spell it with an A. Oh, dagnabbit. Okay, and we're going to go ahead and give these guys a color gray, which I'm just going to say is here, I believe. The size we're going to change to, let's just make it 2, 2. And now we have all the balls. Now we're going to say ball, pointing to add animator. And basically the animator is going to be, I'm just going to have them draw basically every frame. So we're going to say we'll say We'll say 50 plus I. And then 50 plus I plus 1. Okay. And now what we're going to do is we're going to say ball.size. I think it's this way. And the size is just going to grow from vec of 0, 0 to vec of 2, 2. And I believe this is the appropriate notation. Let's see, 0, 30 triangle is I of size, vec 0, 0. Yep, this should be correct. So we're going to change this to 0, 0. Okay. We're going to give this guy a go just to check the animation. And then we're going to figure out what we did wrong with the... no, let's add animator. Oh, that's because I think I forgot a vec animator. And let's just, for the fun of it, bring these guys down to the next line. And X, right. Try this. All right, now we're going to do /Sierpinski, and we're going to do MPV. Perfect. They're all gone. Let's try commenting this out, commenting that out. Let's try building that, and let's see if the gray balls are at least there. Oh, well, they're 0, 0, right? Okay, so we're going to do G++. /Sierpinski. And now let's try MPV. Okay, so here's all the dots. This is fine. The dots are there. I don't know why they weren't animating before. So let's just try I and I plus 1 for these animators. Close there and close here. And let's see what happens if we change this to R00. G++ /Sierpinski. MPV. Yeah, the dots just aren't appearing at all, which is interesting. I just don't know exactly why. I'm not sure. While I'm not a Microsoft fan anymore, I do give them credit for making their own file system, making an operating system that's totally not Unix-based, an Office suite that's great until 365 mess. They made DirectX. They did some pretty cool stuff on their own. Desktop Linux distros were a mess even in early 2000. They've come a long way. Now new Linux is pretty user-friendly for everyone. Yeah, I think I agree with you. Microsoft and Linux, Microsoft Cloud is 32% of their revenue. Let's see. I'm missing a lot of chat, and I'm so sorry about that. Let's see. I don't know if they hate Linux. Let's see. Do you know there was a Netscape navigator that would... Wait, would anybody be interested in a Minesweeper speedrun? Actually, I might. Well, invisible fractals. Yeah, okay, so we'll work on this animator in just a second. So, okay, we'll get the points right in the right location. And then after we get the points in the right location, then we'll try to figure out what's wrong with this animator. I have no idea what's wrong with this animator. So let's see. We're saying if R&D... Let's see if our point is actually random. So we're going to do G++. /Sierpinski. That looks pretty random. I mean, like, I'm not a random judge or anything, but I would say, you know, that's pretty good for randomness. Okay. So that means doing something wrong down here. So we're saying point is going to be equal to 0.5 times point.x, 0.5 times point.y. The lower left-hand point is the one that I don't like. Let's see. What is that what the algorithm I worked on was for? Wait. Could be. Gaming is still best on Windows, even though Steam is pushing Linux. Fair enough. Like, I understand. If you want to do gaming, Linux is probably not your best option. I'm not gonna lie there. It just probably is not. Let me take a look at this MPV again. Oh, the points aren't there. Let me try writing this, going over here, running G++ /Sierpinski MPV. Where are the points? Where? They were just there. What did I do? Where did they go? write this, go over here, compile it. Oh, I didn't, they don't have a size. Okay, fine. Fine. Let's try it again. G++. / Sierpinski. MPV. Okay, my question is, this point's correct, this point's correct. Why is this point incorrect? Where are these dots? Okay. How can we have 2 correct points and 1 incorrect point? So 0.5 times point.x, 0.5 times point.y. Why are 2 of them correct? I have no idea. I don't even know what I'm looking at here. If it's less than or equal to 0.33, if it's greater than 0.33, and less than 0.66, for some reason I've just got a feeling the double rand is never entering this. I'm sorry, I know this is dumb. SED, C out first. All right, let's go. G++, Sierpinski. It is going, it's even going in here. Like, oh, dagnabbit, now what am I doing wrong? I don't even know why. Like, what is your deal? Okay, let me just do second, third. All right, so we're gonna do G++. Yeah, it looks like it's going in all of these guys. So, like, we are adequately changing the point's location. But for some reason... So the first triangle point... How about we just modify all of these guys so that they're all running the same exact code. So this is going to be triangle point of 0.x plus this here. Okay, and we're just going to pop this down to the next line. I'm going to say 0.5 times triangle PTS of 0.y. Okay, and let's go ahead and put a parentheses around here. Parentheses around there. And again around there. And we're just going to do yank to yank, and we're going to paste it down here. And paste it down here. And we're going to delete this line. Delete this line. And we're going to change this to 1. And we're going to change this to 2. Okay, so now we're going to try G++. Error. Okay. What is your problem? 0.5. Oh, I see. That's your problem. Thanks for telling me that. Okay, I don't know. I don't know what the deal is. Don't know what the deal is at all. We're missing all... Ah, we're so close, but it's just not there. What am I doing wrong? Else, if not... Ah, dag nabbit. That is it too, isn't it? That is it. Oh my gosh, I'm such an idiot. Oh, why am I such an idiot? Was that Gathros? Thanks, Gathros. Oh my gosh, thank you so much. Jeez. Okay, well, let's go ahead and remove these C outs. Oh man. Maybe I should do Linux virtual machine Windows. Let's see. All right, so now the next question is, how do we get these animators to work? If we get these animators to work, then I'm happy. So let's go ahead and change this to 0, 0. I see. Yeah, I hadn't thought about that. But thanks, I do appreciate it. Oh wait, that's... Yeah, okay, I appreciate that. Okay, so we have the animator now. So now the question is, why is the animator not working? And for this, I'm not actually sure why this animator is not working. I can think of a couple reasons. And I'm going to try some of these reasons in just a second. So MPV, so we shouldn't see any of the dots appear. Yeah, so none of the dots appear. So what I might do... Yeah, thanks a lot, Gathros. I really appreciate it, by the way. So what I might do is go up here. And I'm going to try something. Something that is kind of a... I don't know if this is actually going to work or not, but... You need access to a lamp that glows if you point out a mistake. That'd actually be amazing. Like if we had some sort of like light in the background that would just appear like as a light bulb if someone got something right. Okay, so we're going to say std vector of similar to above, std shared pointer of ellipse. Okay, and we're going to call this balls. Okay, fine. And what I'm going to do is I'm going to actually push back this guy over here. So we're going to say balls dot pushback. Balls dot pushback. Ball. Change I to 0 and I plus 1 to 30. Let's try that. Before I try doing this weird solution up here anyway. So we're going to do G++. I think you're right. I think I know what the problem is. G++. Sierpinski. MPV. And I think this will actually create what we want to create. Yep, it does. And I think it's because I want to do... Well, let's try 0 plus I minus 20. And let's do 30 plus I minus 20. Okay, so now let's try this. So we're going to do G++, Sierpinski, MPV. There we go. Okay, so now we're seeing all the points randomly appear. That's nice. That's what I wanted to see. Okay, so now the next thing is I'm going to pop up here, and we're going to say I guess it's going to be I, 0 plus I times 10. And then it's going to be 30 plus I times 10. Ah, dagnabbit. Thanks again, Gathros. Really appreciate it. Sorry for that. That command is the best thing we have. Watching Leos. Watching. I really appreciate it. Thank you so much. You're not helping. What do you mean you're not helping? It's doing pretty well, actually. I'm a fan. Like, this is relatively quick. Okay, so now we have 30 plus I minus 20. I'm going to change the size of these guys to, let's just call them 10 by 10. Okay. So we have 10 by 10. We have the vectors being created appropriately. So now we're going to change this to 0. So we want this to be 30 to 60. Okay, and I think I'm only doing 200 frames, so maybe that's my problem. So let's just see what happens if we write this. We go to G++, Sierpinski, U. I changed it. I. G++, Sierpinski. Well, that took a long time to make Sierpinski's triangle. Let's do MPV. So here are the 3 points, and then they're all being created. Yep, okay, I'm okay with that. So now let's see. So we're gonna have at least 1,000 frames then. So let's increase this to, I don't know, let's say 1,200. Yeah, let's do something like that. So now we're gonna do G++, output Sierpinski, MPV, and we'll just watch it for a second. Give it a second. This might be a bit high resolution, actually, now that I think about it. Let's see. James will need to have notification sound for the stream. I could have notification sounds. I don't know. I haven't added those in yet. How do we get a lamp into Leos's house? Ha! Ha! All right, let's take a look. So we have all the points being generated. Yeah, okay. This is getting there. The animation is mostly there. Yeah, okay. So we just need to create basically a high resolution animation for this, and we'll be good to go. So, cool. We might want to do it such that we do 10,000 points instead of 1,000 points. So let's do I equals 0, I less than n. So we're going to do 10,000 points, G down here. But I don't want the animation to be that long, so we'll modify this real quick. So we're going to do 10,000 points. And what I want to do is basically say let's see, how do I want to do this? It's going to be I mod 10, I believe. No. So we're going to go to 10,000, and we just want to divide by an order of magnitude. So we'll say floor of I divided by 10. I know it'll probably automatically floor. I don't know, I'm specifying floor. Of I times 0.1. Oh, let's try that. All right, so now we're going to do this, G++, Sierpinski. And then we'll take a look at MPV, and that should be about it for the stream. I know it's past 7, I need to go. Can you randomize colors and points, green palettes maybe? Maybe some of them on the left darker and other on the lighter. Yeah, we can do something like this. This is totally fine. I think what I'll do, because I'm kind of running short on time, we also need to do something similar for the Barnsley Fern. So I think tomorrow we'll come back, we'll do the visualization for the Barnsley Fern. Ooh, man, I am just... and I don't know when we're going to actually build our fractal Christmas tree. So I think what I'll do... Okay, this is what I'm going to have to do. I'm going to have to do all the audio and video recordings and editings tomorrow afternoon, and basically get the audio and video ready so that I can just put in the animations I need, so that we can do a longer stream on Saturday and we can get the video out on Sunday. That's, I think, what we're going to have to do. So let's do MPV, full screen here, and yeah, that looks pretty good. Something like this. Yeah, okay, I'm a fan. And again, we can randomize colors, we can do a whole bunch of other stuff. We'll work on it. But for now, this is a good first step. Okay, and there's some other stuff that we need to do. So, let's see. I do have to go for now, so what I'm gonna do is I'm gonna go ahead and do git add Sierpinski .cpp and git... Wait, let me look at it. Oh, come on. Is that the right compilation instructions? Yes, it looks like it is. Okay, so we're going to do git commit -m, adding updates to the Sierpinski triangle. Nice. Git push. Origin master. Okay, so the plan is to do the Barnsley Fern animation tomorrow, so we have both the animations ready to go. Then continue working on our fractal Christmas tree, seeing what we can do with it. Hopefully it turns out okay. And then we will, yeah, and then we'll, and then we'll try to make the video on Saturday. I really want this video to be on Sunday, and we are kind of rushing it a bit, but I think we can get everything done. Try Discord PM, apparently got annoying enough. Let's see. Leos would need to run some sort of program. Thanks for stream, have a great day. Okay, so this is it for the day. Thank you guys so much for coming in. Let me see who is online on Twitch. Let's see. We can do Skylius. How about we do Skylius? We haven't done Skylius in a while. Thank you guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos when we work on the Barnsley Fern animation. And then we work on the Fractal Christmas tree, which we are still behind on. So we have a lot left to do. But hopefully we can get everything done by Sunday morning my time. And we'll see how it goes. So thanks again, guys, and I will see you next time. Bye, guys.